So I usually talk about all the type of smart controllers, which I'm going to do it today as well. But I decided to do it a little bit differently. So if you don't know anything about the smart controllers, hopefully by the time I finish this presentation, you know how to at least program one controller that we have been using. And I know from my experience that it's a good product for residential areas, even for public maintained areas. So, which is a evapotranspiration based controller. So first of all, a typical irrigation system has multiple parts in residential areas. There is, of course, irrigation supply line. You have irrigation pipes, mainly PVC pipes, and then unless you have all the school hose to irrigate your plants, you probably would see in that homeowners and residential areas, people have what we call solenoid valves or electric valves. So these are valves that you can control them. Typically people have a timer that timer sends a signal to open the valves and then can send a signal to shut the valve off. So that's takes care of automation of the irrigation system. And there are, of course, sprinklers or drip irrigation system. There are usually pop-up sprinkler heads in urban areas and drip irrigation system. So the main thing about this irrigation system is that the amount of water that they apply is different. And we are going to see that that's very important when we think about programming controllers and make the best use of their ability to automate irrigation management. But irrigation automation is not a good thing by itself necessarily. If you have a timer and you set it and forget it, so this is what happens. Probably this is an exaggeration, but you would see a lot of runoff that we just see us talk about the negative impact of runoff. So it's not all about losing water and wasting water, which is important, but also soil erosion and washing of the chemicals and all the other problems that are associated with over irrigation. But that's something that usually happens when you have a timer, that you don't adjust the timer and irrigation application over time. And that's when smart irrigation controllers come into play. So smart controller, the way that I want to think about it is that an irrigation timer plus a sensor. And based on the type of sensor that is there, you can divide the irrigation controllers to two main categories: weather-based or evapotranspiration or ET-based smart controllers, and soil moisture sensor-based smart controllers. And we have been using some of these products in our research, but our the main product that we have used is our weather-based controllers, and that's what I'm gonna talk about it today. And my personal opinion after doing 7-8 years of research on these products is that they are both types are great, but ET-based with on-site sensors are what I recommend for our region, inland Southern California. If you go to Florida and other humid regions, you see that the recommendations are usually reversed. They promote soil moisture sensor based because these evapotranspiration controllers are not doing really a perfect job to incorporate rain irrigation scheduling. So if you are in an area that you get a lot of rain throughout the year, then probably soil moisture based controllers are better. But for us, most of the evapotranspiration demand happens over the summer, that like 70-80% of the demand is over the summer, that we get little to no rain. I think weather-based controllers are better. And there are products out there that are labeled as smart controllers, but really you should look into the research, the products that researchers and cooperative extension personnel tested them, and they know that what they are really based on scientific methods. Otherwise, there are products that are not really smart, if you will. So for weather-based controllers, there are two types. One type that they come with an on-site sensor. That's the product that I have at home, and I think are the best products. Basically collect or tell you what that microclimate is that Don mentioned correctly. That is really important, as opposed to products that they bring or transfer weather data from nearby weather station which they only work good if the property that use those products are close to those weather stations. So I'm going to talk about weather-based with on-site sensors. So how do they work? They are going to measure or estimate evapotranspiration, which is a combination of evaporation from soil surface and transpiration by plants. We usually combine these two terms and call it evapotranspiration. And there are different methods to schedule irrigation. One method that is even widely used by researchers is ET-based irrigation scheduling. So what we do is that we measure reference evapotranspiration, which is evapotranspiration for a reference crop. It could be alfalfa or cool season turf grass that is shortly clipped. So what it tells us is basically tells us the atmospheric evaporative demand. So if we have no limitation in terms of availability of water, so if we give cool season turf grass as much as water it needs, how much water it's going to use is controlled by atmospheric evaporative demand or weather conditions, if you will. So if it's hot and windy, they need more water. It's humid and it's cloudy, they need less water. So these controllers, they estimate that reference evapotranspiration. But that's only for reference crop. Then the next step is that we say, we assign a plant factor for each plant. And that's something that in my group, we have been doing it. There is, of course, walk holes, and then we are developing some information for our area in inland Southern California. We have tested close to 30 plant species so far. So what is that percentages or plant factor or crop coefficient, there are different names, of that reference crop that the crops that you have is going to use? For example, ground covers, it could be 30% of that reference evapotranspiration, 50%, 70%. The smart controllers don't know it. And we need to program them to tell them what plants you have and what fraction of that reference ET they should apply, okay? So the product that I'm gonna talk about is Weathermatic, a smart controller. And they don't pay me any money to do that, to promote their products. Probably if you use controllers from Rainbird or Hunter, they're as good. But this is just happened to be the product that we have tested over years. So this is more, I think, the high-end product that they have. It communicates with a flow meter, with a wired or wireless sensor, transmit data via cloud to a dashboard, but it's subscription-based that we use for research. Then we can log in, turn on and off irrigation remotely whenever we want. We get to see runtime data. So it comes with a cost, but it's good for research. I have one of these products, but I don't get the subscription at home. So that's a little bit simpler. It's a controller and a weather sensor. And that's what I'm going to do for the rest of this, after talking about zoning presentation, to talk about how to program that particular controller. But before that, one thing that is important is the concept of irrigation zoning. People also call it hydrozone. So the complexity of irrigation management in urban areas comes from having different plant materials. We have trees, usually there is grass, there are drought-tolerant species. So the proper way to irrigate these is to zone them or group them based on the water needs, and then have one solenoid valves that we can assign to each of these groups. And that solenoid valve is programmed to irrigate that particular group based on the water needs. So there are multiple factors that if you want to be really precise, you need to take into account. Microclimate, if it's front yard or backyard is shaded or not, soil condition, type of landscape, but I think that's the most important thing. What type of plant you have. Irrigation system characteristics is important too. I have sprinkler heads. I also swap some of them with drip irrigation. The amount of water that they put is totally different. So that contributes to all the characteristics of each zone. But at least based on the plant types that we have, we should have different zones. Each zone should be assigned to plants that have more or less the same amount of water requirement. So if you have a soil moisture sensor controller, or get a question about soil moisture-based irrigation scheduling, one sensor should be at least in most sensitive zone. If people can afford it, multiple sensors, one per zone. For ET-based controllers, we need to calculate that plant water requirement and runtime for each zone that I'm going to talk in more details very briefly. All right. So this is the controller, Weathermatic. If I think still there are rebates programs. So when I got this, I live in Orange County. It's about $80, $90, I think, with the weather sensor. I got a couple of years ago, and rebate covered almost all of it. So they are very cheap compared to first generation, second generation products, but there are also continuously rebate programs for people to use them. And it's very easy. You just take them out, you install the timer out, you install the controller, and there are controllers that you can operate with battery, but usually you should have access to an outlet. And when you open the controller, there are zones, usually at least they have 4 zones, and each zone, there are 2 wires, one common wire and one signal wire. So let me start over. From each valve, there are 2 wires that are coming to the controller, the common wire and signal wire. Signal wires should not be really bundled together, but common wires, you can bundle them, and there are 1 or 2 slots that you can connect them to the controller. But each signal wire should be connected to one zone, unless you have, for whatever reason, that reality is not perfect. For example, I have 2 zones in my backyard that are all both irrigating my turf grounds. So I actually put them in one zone in the controller. So when the controller sends a signal, it opens both of 2 valves together. That works perfectly for me because also my controller has only 4 zones, but I have 5 valves in my front and backyard. But there is a limit to that. So you cannot connect 5 or 6 valves to one slot on the controller because they just cannot send enough power to open all of those valves. They usually can do 2 or 3 valves simultaneously per zone. But ideally, you want to get a controller that had enough number of zones that you can just assign 1 valve per zone. So for this particular controller, you need to first set it up in basic mode, which acts as a timer, okay? So you first dial it to current date and time. So set time and date, which is very easy. Then program start times. So usually, I think the default, you have up to 3 or 4 start times. So it's very important to program multiple start times. We are not gonna irrigate, so we shouldn't irrigate for a long period of time, let's say 10 minutes, 15 minutes, 20 minutes, because no matter how dry the soil is, it's going to create runoff. So the best practice is what is called soaks and cycle. So you water the plant for, let's say, 5-10 minutes, 5 minutes, I would say, and wait for an hour or so, then irrigate again. So for multiple start times, what I do for zone 1, for example, I do 12 a.m., 2 a.m., 4 a.m. And it's best practice is to irrigate overnight. I see often in my neighborhood that people irrigate in the morning. So that's part of that water goes right back to atmosphere. So evaporative loss because the sun is already out. And usually based on my experience, the wind speed is lower overnight. So you avoid evaporative loss and then also wind drift. Then when you have program start times for each zone runtime, again, my recommendation for typical pop-up sprinkler heads is no more than 5 minutes. 5 minutes, maximum 10 minutes. And you can do it, little test. Just run it until you see there is a runoff and then time it. That's the maximum time that you want to run it before you let it soak. Next is days to water. And you can see that I'm following this controller. Zone runtime and days to water, of course, is your watering days. Each municipality usually has restrictions, 3 days, 2 days, what days to irrigate, so you can set it up here. So that so far is just a timer that you probably are familiar with. So once we are done with setting it up as a timer, the next step, we are going to set it up as in a smart mode. Setting it up correctly in a timer, it's a good practice because if for whatever reason controller switch backs toggles between a smart mode and basic mode, we want to set it up in smart mode. At least in basic mode, we have some settings, some programmings that are realistic. So, and controller can follow them without really excessive water application. Then we go to smart mode. So the first thing is to set up the zip code. Why zip code is important? It's really important. It's because the way that these controllers work, most of them, they hopefully you still remember that they calculate reference ET or water need for that reference crop. The way that they do it, they come with a on-site weather sensor. This is nothing but a temperature sensor. So they measure temperature, but they also need solar radiation information to calculate reference ET. That solar radiation is based on location. They estimate it. So when you enter zip code correctly, they calculate solar radiation that doesn't change much over time based on your location. So solar radiation based on location, so proper zip code, and air temperature that they measure using the sensor. Then they calculate reference ET. Second, so where are we? Zip code, and then we go to a sprinkler type. These are number 2 to 6 to 5. You should do it for each zone separately. So what type of a sprinkler or irrigation system you have? There are pre-programmed irrigation system types in the control that you can use. But if you have more information that how much water exactly is being applied by your system, most of these controllers, including this product, they let you input that. So I don't know, 1.2 inches per hour. That's what we do for research. We measure exactly how much water our system applies. But if you don't know it, that's okay. You can just use it from the drop-down menu that is there. Third, plant type. Before I talk about plant type, this sprinkler type is extremely important because the controller calculates behind the scene how much water you need to apply, but that's millimeter of water, volume of water. It doesn't know how it should convert it to runtime. The way that it does it, it's based on your input. So if you don't input it correctly, it's just not going to work properly. It should know, for example, to apply 1 inch of water, it should run for 30 minutes or 1 hour. That's when your settings for type of sprinkler or how much water your system applies is comes into play, and it's very important. So next, plant type. So that's the area that you say, okay, I have shrubs, trees, there are pre-populated plant factor information. Or if you use the information that, for example, we develop or locals for a specific species, you can enter it. That's just, remember, fraction of reference evapotranspiration. It tells your controller that, okay, you're calculating how much water a cool season turf needs, but my plant needs, for example, 30% of that, 20% of that. And if you don't know how much water your plants need, usually I would say start at 50% for ground covers, and then just dial it back over time. Go 40%, 30%, until you get to that right level of application that works best for your soil type and plant type. Number 4 is soil type. What type of soil you have and slope. This soil type and slope doesn't change irrigation application. It rather changes the irrigation runtime and soak. When you switch to a smart mode, it's going to run a soak cycle based on the soil type and slope. So if you have a slopey site and a soil that is really heavy, it's going to run it for shorter period of times and longer soak time to avoid runoff. 5 is more and less. You can leave it, it's optional, but if you know that, for example, you have a site that needs a little bit less water because of the shade, that's when you can include it. Zone 1, it's turf grass, use crop coefficient, but apply 20% less because I know that because of the shade, the requirement is less or more. So you can do that here. Or to take the irrigation efficiency or distribution uniformity into account, you can do it here. Next, omit times and days. This is very important. This is not really part of the smart setup, but I do it for my research and at my home. If you don't limit the controller in terms of the hours that they run irrigation, then you can see that the sprinklers will pop 2 p.m., which is not really ideal. So what I recommend is at 10 p.m. to 6 a.m. Just limit the irrigation to that time frame. Then the controller knows that they are not supposed to irrigate outside of that window. Some extra final adjustments. So we talk about omit times and days. In advanced mode, there are a couple of other things that you can set and check. One is number of start times. By default,
Yeah. I don't even need.
by default, it's 3 times, but you can go up to 9 times. I usually set it at maximum. So then that allows you, when you first set up the controller for not the smart mode, but just the simple mode, you can actually assign multiple runtimes. Rain delay, this is very important. So this little sensor, even if you have a timer, I think you should install these sensors or get a timer that are the incorporate sensors, because what I see often is that people irrigate right after rainfall, or worse than that, during rainfall. So this sensor has a little rain sensor on top of the temperature sensor. That rain sensor is not only going to shut off water during rain, but also usually for 24 hours, or sorry, 48 hours, they are going to stop irrigation, which is really important because we usually get enough rain. But you can also change that. If there are rains, or typically in your area, they refill the soil for 3 days, 4 days, you can increase that, I think, to up to 9 days. Last but not least, I talked about the importance of not irrigating too much at once, but also irrigating too little is bad, because it's just not gonna percolate and refill the soil profile. So there is this function that is called minimum deficit under advanced mode, that is telling the controller that don't irrigate unless you get that level of deficit in water, in the soil. So I set it to maximum amount, that is 0.5 inches for all my zones. So what this controller does then, it's going to every day keeps track of what is the evaporation demand from the atmosphere using that soil moisture, the weather sensor. When it gets to that 0.5 inches of deficit, then it's going to irrigate to replace that. All right. So I'm almost done. We put together a couple of extension papers that are meant to keep them simple and short. One of them is specifically on the smart ET-based controller. So you have more questions about how they work in terms of the theory behind them and rebate programs and everything else. You can check this on my website for free. That is ucrwater.com. I'm gonna show you that in the last slide too. So to wrap it up, there are 2 types of controllers: weather-based and soil moisture-based smart controllers. So the way that they work and help you save water is by adjusting irrigation amount and frequency for each soil and plant type. So the controller should be a type of controller that researchers have tested them before. Also, you need to program them correctly. Irrigation zoning is very important. Otherwise, they are not going to really give you the highest benefit that they can. And there are rebate programs to purchase smart controllers in Southern California. This is again my website. You go to ucrwater.com under publication, go to extension publications. There is also presentations. If you go there, you can see all of the presentations from previous field days that we had, where folks who are interested in native species. We covered them 2 years ago, and I think even 4 years